Imagine a world where everything is reversed. Up is down, left is right, black is white. This isn't just a thought experiment, it's the reality of antimatter. Antimatter is a strange and fascinating concept. For every particle of matter we know, there's an antiparticle. An antiparticle is like a mirror image of its matter counterpart. It has the same mass but the opposite charge. Think of it like this. You have an electron, a tiny particle with a negative charge. Its antimatter twin is the positron. The positron is also tiny, but instead of a negative charge, it has a positive charge. It's like the electron looked in a cosmic mirror and saw its opposite self. This idea of antimatter isn't just science fiction, it's a fundamental part of our universe. Scientists have proven its existence. They've even created small amounts of antimatter in labs. Antimatter is a mystery and a promise. It's a mystery because we still don't understand everything about it. It's a promise because it holds the potential for incredible energy and advancements in space travel. The story of antimatter starts with a brilliant physicist named Paul Dirac. In the 1920s, he was working on equations to describe the behavior of electrons. His equations were like magic spells, revealing hidden truths about the universe. But these equations held a surprise. They predicted the existence of a particle just like the electron, but with a positive charge. This was a radical idea. No one had ever seen such a thing. Dirac's prediction seemed too strange to be true, but just a few years later, in 1932, the impossible became real. A physicist named Carl Anderson was studying cosmic rays. These are high-energy particles that rain down on Earth from space. In his experiments, Anderson found something astonishing. He found evidence of a particle that acted just like Dirac's predicted anti-electron. It had the same mass as an electron, but a positive charge. This particle was the positron, the first antimatter particle ever discovered. Dirac's prediction and Anderson's discovery opened up a new realm of physics. The universe wasn't just made of matter, it also contained antimatter, a mirror image of the familiar world. The true wonder of antimatter lies in what happens when it meets matter. When matter and antimatter collide, they annihilate each other in a burst of pure energy. This isn't your everyday chemical reaction like burning wood. This is a complete transformation of mass into energy, as described by Einstein's famous equation, E equals mc squared. Imagine throwing a baseball into a fire. The baseball burns up, releasing heat and light. Now imagine that baseball colliding with an anti-baseball. The result wouldn't be a small fire, it would be a massive explosion of energy, far greater than any chemical reaction could produce. This annihilation process is the secret behind antimatter's potential as an energy source. A tiny amount of antimatter can release an enormous amount of energy. In fact, antimatter matter annihilation is the most efficient energy-releasing process known to science. If antimatter is such a potent energy source, why aren't we using it already? The answer lies in the immense difficulty of producing and storing it. Creating antimatter isn't as simple as flipping a switch. It requires enormous amounts of energy and sophisticated equipment. Scientists produce antimatter in particle accelerators like the Large Hadron Collider. These massive machines smash particles together at near light speeds. These collisions can create tiny amounts of antimatter, but the amount of antimatter produced is minuscule. We're talking about billionths or trillionths of a gram. And the process is incredibly inefficient. It takes far more energy to create antimatter than we can get back from its annihilation. Imagine trying to fill a swimming pool with an eyedropper. That's the scale of the challenge we face in producing large amounts of antimatter. Section 5. A delicate balancing act, storing antimatter's fury. Producing antimatter is only half the battle. Once created, it needs to be stored safely, which is no easy feat. Antimatter is highly reactive. If it comes into contact with ordinary matter, even the air we breathe, it will annihilate in a burst of energy. To prevent this catastrophic reaction, scientists have devised ingenious methods to contain antimatter. They use magnetic fields to suspend antimatter particles. These fields act like invisible bottles, trapping the antimatter and preventing it from touching any matter. But these containment systems are delicate and require constant monitoring. Any malfunction could lead to a catastrophic release of energy. Imagine trying to hold a miniature sun in your hand. That's the level of care and precision required to store antimatter. Antimatter's potential in energy. Despite the challenges, the potential of antimatter as an energy source is too great to ignore. Imagine a world where power plants are fueled by tiny amounts of antimatter, producing clean and efficient energy. A single gram of antimatter could power a city for a year. Antimatter could revolutionize energy production, reducing our reliance on fossil fuels and mitigating climate change. It could provide a clean and sustainable energy source for future generations. But these dreams of an antimatter-powered future are still a long way off. The cost of producing and storing even small amounts of antimatter is astronomical, making it currently impractical as an energy source. Section 7, To the Stars and Beyond, Antimatter for Space Travel. Antimatter's potential extends beyond our planet. It holds the key to unlocking interstellar travel, allowing us to reach distant stars and explore the cosmos like never before. Current rocket technology is woefully inadequate for interstellar travel. Chemical rockets are simply too slow and inefficient to cover the vast distances between stars. Antimatter propulsion offers a solution. Imagine a spaceship with an antimatter engine. The annihilation of matter and antimatter would produce an incredible amount of thrust, propelling the spacecraft at a significant fraction of the speed of light. Such a spacecraft could reach nearby stars in a matter of years or decades, rather than centuries or millennia. While still in the realm of science fiction, antimatter propulsion is a tantalizing possibility. It could be the key to unlocking humanity's future among the stars. Section 8, The Double-Edged Sword, Ethical Considerations. With great power comes great responsibility. Antimatter is no exception. While it holds immense potential for good, it also presents significant ethical concerns. The destructive power of antimatter is undeniable. In the wrong hands, it could be used to create incredibly powerful weapons, far more devastating than any nuclear bomb. The thought of an antimatter bomb is terrifying, and the possibility of such technology falling into the wrong hands is a sobering thought. Furthermore, the development and use of antimatter technology raise questions about unintended consequences. Could accidental releases of antimatter pose a threat to the environment or human health? These are questions that require careful consideration as we explore the potential of antimatter. Section 9, Antimatter Accidents. Do we need to worry? The idea of antimatter accidents might conjure up images of catastrophic explosions, but the reality is far less dramatic. While the energy potential of antimatter is undeniable, the amounts currently produced in laboratories are so minuscule that they pose no real danger. Imagine a single grain of sand. Now imagine a billionth of that grain. That's roughly the scale of antimatter currently being handled by scientists. Even if an accident were to occur, the resulting annihilation would be equivalent to a tiny spark, hardly enough to cause any significant damage. The real dangers of antimatter lie in the future, if and when we develop the capability to produce and store large quantities. Until then, the risks associated with antimatter accidents are more theoretical than practical. Section 10, Science Fiction or Future Reality. Antimatter's place in our world. Antimatter has long been a staple of science fiction, fueling the engines of starships and powering futuristic weapons. But is antimatter destined to remain in the realm of fiction, or does it have a place in our real-world future? The answer is both. While we may not have warp drives or antimatter bombs anytime soon, antimatter is already playing a role in our lives. Positron emission tomography, or PET scans, used in medical imaging, rely on the annihilation of positrons to create images of the inside of the body. In the future, antimatter could revolutionize energy production, power interstellar spacecraft, and even treat diseases like cancer. However, achieving these goals will require overcoming significant scientific and engineering challenges. Section 11, Conclusion. Antimatter. A universe of possibilities and challenges. Antimatter is a captivating enigma, a mirror to our own existence that holds both immense promise and significant challenges. It is a testament to the power of human curiosity and ingenuity that we have been able to unlock the secrets of this strange and powerful substance. The journey into the realm of antimatter is just beginning. As we continue to explore its properties and develop new technologies to harness its potential, we can only imagine the incredible discoveries and advancements that await us. The future of antimatter is a universe of possibilities, waiting for us to unlock its secrets and shape its destiny.